Right, afternoon everyone. As promised, here's a screencast on chromatography. Chromatography is one of the required practicals for GCSE, and obviously we're not in a position to do that. So I'm going to talk you through a few bits and pieces about chromatography, and then there's a worksheet for you to do and a couple of videos of the practical itself. So the main focus for us is what's called paper chromatography. You can see from the table top left there that there are other types, but we're most interested in paper chromatography. The amount or the distance that the different substances move up the piece of paper depends on, well, you can read that as well as I can, the relative strength of attraction, or fancy word affinity, of each substance to the mobile and stationary phase. And the mobile phase, or the mobile part of paper chromatography, is the solvent, and the stationary phase, the bit that does not move, is paper. Now, this diagram is quite important so that you get your mind, or to help you get your mind round what goes on. Now, one here is the solvent. That can be water, it very often is, or it can be something else, methanol, ethanol, nail varnish remover, acetone, all sorts of different things. It depends on your mixture that you're going to try and separate using chromatography. Now, it doesn't take a genius to work out what 2 is, which is why I can do it. 2 is the paper, and in this particular picture it's suspended in a tank. It could just be suspended over the top of a beaker down into the solvent. Now, the level of the solvent must be lower than this dotted line here. We'll come to that dotted line in a minute. Now, 3 is where you put a spot, small spot as possible, of your unknown substance that you're going to investigate. Then 4 are 4 spots of substances that might be contained in your unknown mixture. And you run those, yes, that's the technical term, next to the unknown substance 3. Okay, so you put 5 little spots on that line there, that line number 6. I'm going to do 6 before 5 because it makes sense to me, even though whoever set this up doesn't agree, obviously. 6 is a line that must be drawn in pencil. If you draw it in ink, then it will run and make a mess of your chromatogram. And if you draw 6 in a place where it's below the level of the solvent, so in other words dipped into the solvent, all these spots will just wash off, and so you'll have completely and utterly wasted your time. So it must be drawn in pencil. So the solvent should come to a level sort of like where I've just gone across there, below your pencil line. And over time the solvent moves up the paper, and you start to see these different coloured spots as it moves. And eventually it gets to, well, don't go to the top, but stop about 1 centimetre or 2 from the top. And there you get what's called the solvent front. That's where the solvent has moved up to. And you then would take your chromatogram, that's the fancy word for this bit of paper here, your chromatogram out of the tank, draw a pencil line across there to mark the solvent front, to put where the solvent has travelled to, and then you'd put your piece of chromatography paper, your chromatogram, onto a radiator, one of the nice hot radiators in S1, to dry off. Now, what can you deduce from a chromatogram? Well, I can deduce that those 2 substances are the same. Those 2 substances are the same. Those 2 are the same, and those 2. So that tells me that my mixture 3 contains all of these substances. How do I know they're the same? Well, 2 things, one of which we'll come on to a little bit later. First of all, they're the same colour. Okay. Second thing is they have moved the same height. So same colour, same height, but there's a little bit more detail to add on to that same height in a little while. So I can tell, because there's only one spot, that was a pure substance, one spot, that's a pure substance, but 3 is a mixture of 4 substances. So now there's a little analogy. You can read that as well as I can. I'll pause the video for a second, and you can do the same just while you read that, just to give you an idea. But might help, might not help, but we'll see what you make of that little analogy about how chromatography works. Okay, get it from that? Hope it helps. So now, here is a chromatogram. Unknown substance P and A, B, C and D known substances. Okay, first of all, can you deduce how many different substances make up the mixture P? And secondly, can you deduce which of A, B, C and D make up P? Okay, again, I'll just give you a short amount of time to have a think about that. You can pause the video and then I'll tell you what sort of things you could have deduced. You have paused that video, haven't you? Good. Okay, so I can deduce that P is made up of 3 different substances. It's not made up of D, it doesn't consist of D. It consists of C, because it's got both those spots in. C is also a mixture, not a pure substance, you'll notice. Hasn't got B in it, there's no red spot here, but has got A in it. There's a yellow spot at the same sort of height. Okay, so P is a mixture of A and C. And now here's the more technical bit. And there's some practice on this on the worksheet I've sent on or put on Google Classroom for you. Now this thing called RF. What does R stand for? Relative. What does F stand for? Well, okay, whatever you want it to stand for. But it's the distance travelled by the spot. You measure the distance to the middle, and then the distance divided by the distance the solvent has moved. So in this instance, the middle of my spot is 7 centimetres from the start line, and the solvent front is 10 centimetres from the start line. So 7 over 10 is 0.7. This is the sort of calculation you have to do on exam papers. I would criticise this slightly by saying perhaps it should be 0.70, but 0.7 will do. RF values are often given to 2 decimal places. Now, this is relatively easy to do. You've just got to take care with your measuring and make sure that the value is less than 1. If you get a value greater than 1, you've done the sum the wrong way up. Okay? Now, what use is this chromatography? Well, you may have used it to separate dyes in Smarties when you're in year 8 or something like that. Yeah, that's all fascinating, but it can be used in food testing. There was a case a few years ago where chili powder from certain supermarkets contained an illegal substance. It contained a substance that was a carcinogen, and they actually found out by routine analysis of the chili powder by chromatography that it contained this illegal substance. Doing the same sort of comparing that you'd do, or that was done on those previous slides, they found it got this substance that was not a permitted colouring, and Asda, Iceland and places like these had to remove all of this chili powder and certain ready meals from their shelves. I think from memory the dye was called Sudan Red, so if you Sudan red, so if you want to look that up, you might be able to find the story about it. Okay, so watch the 2 videos about the practical, and then please have a go at the worksheet. Okay, that's enough waffle from me. See you soon. Bye.